Hello class, and welcome to week 11. Today we are going to start a really important topic in programming in general, and that is object-oriented programming. And what object-oriented programming is the idea that with our larger and larger programs, the larger our programs get, the more there is a need to reorganize our code. And the easiest way to organize your code, or the way that the godfathers of programming decided would be the best way to organize our code, is to organize them into objects that model real world objects, or in other words, whatever it is that we're programming about, all of the nouns that appear in our programming. If we can put all of the data and the functions that are associated with that thing into a unit, a portable unit, then we can more easily maintain our code. So I'm going to start a brand new project here. And file, new project, and I'm going to call this TMNT classes. This is an example that I wrote myself, of course, and what we're going to do is we are going to create a class called Teenage Mutant Ninja Turtle, or TMNT, and then we will implement that class in our main function. So I'm going to create a new folder here, and I'll call it the same thing, classes. Okay, so this is my where my main function will be. The class itself will be in a separate header file, a lot like our database accessor that we created. That was something that was portable. The same idea holds for class structures. If you create these classes that are standalone and portable, then you can reuse them in your projects. And in programming in the business world, that's a very common thing. You might need to use that object or that class, in one project as well as the others. For example, in my workspace, we sell ATMs, and then we sell service contracts on those ATMs. So I created a class for service calls. Although that's not a tangible thing, that's a little bit more abstract. It's still a noun. It's a thing that has data and methods associated with it. A more concrete thing, object that I created at BankSource is a invoice. So there's an invoice class for all the invoices that we create. I've got an equipment class, maybe even more tangible there. All of the pieces of equipment, all the ATMs that we sell, that we have under contract. I created a class for those. So all the serial number, all the data associated with it is in a single class, and then I can put that into all my projects. So let's create a brand new file here. It's going to be a new header file. So it starts out as untitled, and I'm going to do save as. So save it in that area, and let's just call this TMNT, and make it a header file instead of a C++ file, tmnt.h. Okay. So my Ninja Turtle header file, just like our database header file, if you want it to be portable, not a bad idea to put your include statements there. Okay. And then my using namespace standard. Okay, from the text and from the PowerPoint notes this week, you should have seen that when you create a class, you start with a keyword class, and then you give it some sort of name. I'm going to actually call this class NinjaTurtle. And really, your class name, that way, if you've got a single class for a file, it might be better to have the file name match your class name. I'm going to go ahead and do that on second thought here. Whoops. And if I close this and then reopen it, I'm going to reattach it. Add to project, NinjaTurtle. So it saved it with the new name over top, or in addition to the old, since I had it open, I guess. I'm going to delete this one. Open that one. Okay. It deleted all the stuff I wrote as well. Okay, and something that's different about the class, there is a semicolon you place at the end of the braces. So this is letting the compiler know that this isn't a function, this is a structure, a class, an entire class. And so open close braces with the semicolon. Okay. Within the class, we can define things as public and private. So public things, of course, can be used outside of the class or can be accessed by other parts of the program vis-a-vis the main. And then the private aspects of your class can only be seen within the scope of the class. So class structure kind of solves that problem. Remember we talked about global variables and how global variables aren't a good idea because they're hard to maintain, and you might have thought, well, man, it would have been a lot easier to write this program if I could have just put a global variable up there. Then all of my methods could have seen the data or seen my variables, and then I wouldn't have had to pass that data around like a hot potato. Well, the godfathers of programming saw that same issue. They wanted to be able to create these variables that are seen by multiple functions so you don't have to pass them around, but not seen by every function. So that's what a class does. It just lumps your data and your methods or functions together in a single entity, and then you can create these variables that are global to the scope of the class but can't be seen elsewhere. So I'm going to start with my data. Typically you make the data private, that way all the methods can see it. So I'm going to create a string for the NinjaTurtles name. I'm going to create a string for their color, and then a string for their weapon. And then what you do, this is just good class structure. Make your data private, and then have your functions give the user access to the data, as well as perform whatever calculations that you want on the data. Okay, from this chapter, another really important aspect of a class is the class constructor. So what we're actually going to do is when we implement this class inside of our function, main function, we will be carving out in memory by when you create an instance of a class, the compiler carves out in memory a space for all of the data, and then any of the functions you want to use, you can use just by using that dot operator. So we've used classes before. Our input file stream and output file stream, those were instances of a class. We would create an instance of that, and then we would give it a name, and then we would use it. And that dot operator using like dot open to open the file stream and dot close. The same is what we will do with this NinjaTurtle class. So the constructor is a special method that does this. It carves out in memory the area of, for all of the private data, or all of the data, whether it's public or private, all of the variable storage locations. And the constructor is special in that it does not have a return type, and it takes the name of the class. So here, NinjaTurtle, I'm going to create two versions of my constructor. This constructor here is what's known as the default constructor. And what the default constructor allows you to do is create an instance of this class without knowing what the actual data is. You can add that later. So this just carves out in memory the space for the data, and then creates that instance. Now, what if you do know the data when you first create the object, and you want to go ahead and initialize that object with all of the pertinent data? Well, that's what an overloaded constructor can do for you. Here I'm going to create this constructor that receives the name and the color and the weapon. So then the constructor is responsible for initializing this data with the information you pass to it. So I'm going to store into name what I'm passing to the constructor, the string name. I'm going to store into color string color, and then store into weapon string weapon. Okay, so we have two constructors, no return type, and they take the name of the class. Okay, now currently the constructor is the only way that someone who uses the class, if I create a NinjaTurtle here in my main, the only way that I can access that data currently is that constructor, because these are all marked as private. What if I want to change that data later on? Okay, we create, in order to do that, we create functions that will allow the user to get and set, or allow the programmer to get and set the data, and those are called getters and setters, or mutators and accessors. And typically, the way they're written, the get function has the return type of whatever it is you're getting, so string get name, and oops. And what that get name function is going to do is just return the NinjaTurtle's name. That way I have access to that private data. So your functions serve as kind of the gatekeeper for this data. So if you wanted to, for example, in the setter, which has a void return type, if we wanted to reject any of the data, for example, yeah, the NinjaTurtles could only have one of 4 names. If it's not one of those 4 names, we could reject it and say, you know, that name isn't acceptable. I want to do that actually later on. For now, let's just go ahead and let the user pass whatever name they want to. And we'll set it here. So name equals string name. Okay, and then we need to do this same thing. We need to create a getter and a setter for these other 2, the color and the weapon. So I'm going to copy those, paste them, and just change the names here. This should be get color, return color, and this will be set color, string color, store that into color. Okay, and then one more for the weapon, string get weapon, return weapon, set weapon, receives the weapon, and then stores that into the local weapon variable. Okay, so we've got all of our getters and setters, or accessors and mutators, for that data. I'm going to create one more function here. I'm going to call it toString. And what this function is going to do is it's going to just display all of this user's information. And combine it into a single string. So actually, I'm going to give it a string return type, and I'm going to return this name plus, and I'll say where's and then I'll put the color, and I'll say and fights with that weapon. Okay. Okay, so we've created a class. We've taken all of the methods and the data associated with an object, a Ninja Turtle, and we have put them into a single structure. And now we can implement that. Okay, so in the main, first we need to include that Ninja Turtle header file. And when you include your own header files, remember you do type the .h and you put it in quotes instead of these angle brackets. And you know what? I think from now on I'm going to stick these down here below my description. I think the description should probably be at the top. Okay, and I'll put my descriptive stuff here. Oops. I'll say this program demonstrates class structure and implementation of that class. Okay, so in my main, I am going to create a vector to hold all of my Ninja Turtle objects. So I'm going to do vector Ninja Turtle, and I'll call it my turtles. Okay. And so if I want to use vector, I need to include the vector class. Okay. And then I'm going to create some variables here to receive the information from the user. We could reuse a single one, I guess, string info. Okay. So I'm going to start with creating that instance of a Ninja Turtle where I know all the information. So I'm going to do this, Ninja Turtle, and maybe call it Dawn. And this is how you call the constructor in C++. You call it connected, you put the parentheses connected to the instance name here, which is Dawn. So this is the class, and then this is my instance name. I'm going to pass to it the information Donatello, purple, and bow. And then I want to add that Ninja Turtle to my vector, so I'm going to do this. My turtles, push back, and pass to it Dawn. Okay. Then I'm going to display that information my turtles start at 0, and so that returns, since my vector is a vector of objects, that function will return a Ninja Turtle object, and then I can access the functions from the Ninja Turtle class with that dot operator. I'm going to call this toString method. So toString, and I want to display this to the screen, so I'm going to do cout. Okay. Okay, I'm going to compile it at this point, and it's asking me to save my main. That's cool. Save it there. Okay. Oh, misspelled turtle. Ninja Turtle. And here I forgot the word string. I'm sure you caught that, didn't you? Let's try it again. Okay. Compile and run. Okay, Donatello wears purple and fights with bow. So what that did here, that carved out in memory this, called this constructor, stored all the information that I passed to it, Donatello, purple, and bow. It stored that into these local variables here, and then when I called the toString method, it pulled them back out and built a string with them. Okay, so that's what a class is. It's taking data and methods, functions that go together, that represent a thing, a real world thing, and then you have it as this entity that you can do stuff with. You can put it in a vector, you can pass it to a function, you can do whatever you want to it. It's its own entity, and you can create more of them. That's the other idea with a class, is that this class is a blueprint for what that particular object should be like, and then you can create separate instances of that class, and each instance holds its own set of data, and thus it's a unique instance. Okay. Now let's try doing the same thing, only using those getter and setter functions, allowing the user to type those things in one at a time. So I'm going to create a loop here, a do-while loop. I'm going to have this do-while, I'll say string continue is equal to yes. Okay, so let's create that string. Okay, so you're probably wondering what this was there for, the string info, because we hadn't used it yet. Well, that's what I want to use it for. Here is I'm going to prompt the user, enter the turtle's name, and I'm going to use the getLine function, getting from this keyboard, which is a cin stream, and placing it into string info. So then what I'm going to do is I'm going to create an instance of that turtle and then start adding that information. So I'm going to actually create that instance up here. And call it next turtle. Okay, there I'm calling the default constructor, which will invoke this function, which doesn't do anything other than, although you didn't write any code here, we didn't write any code here, what that constructor will do anyway is, or always, is it will create in memory storage space for these three data members. Okay, so now I am going to put that information into that turtle. So I'm going to do next turtle dot set name, pass to it string info. Okay, and I'm going to do this same thing for the other two pieces of information. Enter the turtle's color, and we can still use string info, but then instead of set name it's set color. And then one more time for the weapon, and actually on the Ninja Turtle package it calls it a wacky weapon. Set weapon. Okay. Okay, so now that I've created all that information for that Ninja Turtle, I'm going to add that Ninja Turtle. to the vector. And then we'll ask the user, and here, and make sure you don't copy that. Instead of Dawn here, we want to add next turtle. Next turtle. Okay. And then we'll prompt the user. And do you want to create another turtle? Have them type Y for yes. Get line cn string continue. So while string continue is equal to Y, then it'll loop back. And then down here, now we don't have just a single turtle. See, I hard-coded that 0 in. Let's create a for loop for int n equal 0, n less than my turtles dot size n plus plus. Okay, and then instead of at 0, will be at n. Alright. Well, let's give this a whirl. So this error here, where it says that the function is of non-class type NinjaTurtle, this is a really misleading error. The real issue here is the constructor. When you want to use the default constructor, you actually don't do the same thing as you do when you call the constructor that receives data. So here, where you see the open close parentheses, remove that, and that will take care of that error. Okay, down here I accidentally had one extra parenthesis. Okay. Alright. Enter the turtle's name. We'll do Leo. Enter the turtle's color, blue. Wacky weapon, katana. Do you want to create another turtle? Yes. Let's do Michelangelo. I think that's how you spell it. He is orange, and he uses the nunchucks. Yes. Last turtle, Raphael. Red. Sai. Okay. Donatello wears purple and fights with the bow. Leo wears blue, fights with katana. Michelangelo wears orange and fights with the nunchucks. Raphael wears red. So I forgot my end line here. Stick an end line. Okay. Okay, so that demonstrates using a class, implementing a class as an instance, a user-defined class. And again, the whole purpose of doing this is to have all your code organized based on the object. So let's say, hey, I wanted to add another piece of information to my program. This is a common thing in the business world. Well, hey, the users need to see this particular piece of information now, like an address or a serial number or something like that. Well, you can just go back into the class. Let's say I want to add one thing to NinjaTurtle, their age. Let me add it up here first, and I'll have it as a string. Actually, you know what? Let's do it as an int. That way I can demonstrate how to make that conversion. Okay, so then if I want to add something to a class, I know right where to go. Well, go to that class, add whatever piece of information you want, and then make that change throughout. Okay, add the age to the constructor. Age gets an age. Okay, and then let's add that here. So get age, and we'll make this an int. Return age. Void set age. And actually, with this set age function, let's have it do a little bit of validation. Let's have it be a Boolean function, and it will return whether or not the age is acceptable. So Ninja Turtles are all in the teenage age, right? Teenage Mutant Ninja Turtle. So I'm going to create a function here, or create a decision structure here if and this, let's change this to age string. Instead of string age, it needs to be in age. So I'm going to do if in age is greater than 19 or in age is less than 13, and then we'll issue an error message. Actually, let's do that in the function. We'll say return false, else it'll set the age and then return true. Okay, so what this function is doing is it's going to sets Ninja Turtle age if value is teenage years. Returns false if age wasn't set, true if it was. Okay, so this is the whole purpose really of having getters and setters. In other words, this is the purpose of having functions give access to the data here, as opposed to if I made these public, then the user could just store information directly into that into those storage locations, and there wouldn't be any input validation. So what we're doing here is we're building the input validation into our class. Okay, so then how do we implement this then on the user side? Well, if I go here, we need to create a storage location for that int. So I'll do int in age, and Donatello needs an age in there. Okay, if you can see by this picture, Donatello's age is actually 15. Don't know if you knew that or not. Okay, then in here we want to add that information, so I'm going to hit enter, give myself some space. With the age, it's going to require a little bit more information. What happens if the user types in an age that's not appropriate? So I'm going to have an inner do while here. I'm going to do while not next turtle set age, passing to it age. Okay, so inside this do while loop, I'm going to prompt the user for the turtle's age. Enter the turtle's age, and then read that in. Remember, our getLine functions don't allow you to pass a string or an integer. It has to be passed into a string. Now we could convert that string to an integer. There's a function that does that, but I'm just going to do it this way: string int age, and then I'm going to put a get character function here. That will absorb that enter. Since they say be careful. You have to be careful if you're using get lines in conjunction with the regular cin operator. So that will do that. Okay, so what this will do is receive the age. It will store it into inAge, and it will pass that into setAge, and setAge is going to try to set the age. If it is outside that range, it'll return false, and then this will receive false, and it will loop back, since that's what that not is for. Okay. So also maybe here I'll say teenage. That way the user knows if it loops back, then they did something wrong. So let's compile that and see how well we did. Remember, if you're making changes to multiple files, I would recommend compiling this, do this rebuild all first, and then run it. That way it recompiles the header file. Okay, so now we'll do Leo, blue, and his wacky weapon, katana, and then Leo's age. And if you look at that picture, Leo is 16. Okay, do you want to create another turtle? Yes. Enter the turtle's name. I'm going to shorten these up. Mike, orange, wacky weapon, Chakas. Age. I'm going to put an age in here that's not teenage, like 20, and it'll just loop back. See? And Michelangelo is actually 15 and a half, but we have an integer here, so that'll get cut off anyway. Create another turtle, yes, and we'll make Raphael, and he's red, Psy, and he is 15. Okay, Donatello wears purple and fights with bow. Leo wears blue and fights with katana. Alright, so this demonstrates how you can take your data here and then all the functions that are associated with that data, put them into a singular thing, call it a class, and then you can create instances of that class. It carves out in memory, storage location. And so each one of those Ninja Turtles we created has a separate storage location in memory with its own data. And as you can see here, we programmed this in the general. I just cycled through this entire vector of Ninja Turtles, displayed their information. So each one was a separate one. So an instance of a class or an object is kind of like a variable. You might refer to it as a hypervariable. But so that demonstrates that. Happy programming. Just submit this to me on Blackboard, and we are going to look at derived classes, the second half of Chapter 10 information here in the next video. So make sure you know yourself.